I am going to turn us back to the model. So I had noted we're going to extend the model that we started building up yesterday. So I happen to have loaded another model, so I'm going to close that here. And I want to bring us back to that model which we had constructed. You may recall that this was a very, very simple model. We had theory of personhood with person here. We had the global environment, and then we had a population of people. And we had introduced into the person, for the sake of illustration, an age parameter. We're going to be coming back and modifying that later, but to show the effects of heterogeneity and the assumptions about a person's age. So a parameter encodes assumptions, and it communicates those assumptions from the point of creation to the thing that contains it. In this case, the thing that contains it is a person. So every person has a particular age. And the fact that this is at a person level, within person, means that each person can have their own age. The assumptions to use for those people are set by the population in which they're embedded. We're going to see it gets a little bit more textured when we start to have open populations, people coming in, and we'll see that. But here, for the people in the population from the get-go, when they come in, they're at the beginning of the model, start of the model, their population, their age is drawn from this distribution. Remember, each person has their own age, and this is the formula we're using to determine the age for a given person. It's drawing from a uniform, continuous distribution, continuous uniform distribution with a lower bound of 0, higher bound of 75. Okay. But the more powerful thing yet is we had this dynamics induced on a person. So we had a simple dynamic theory of personhood where people start off with a healthy heart. That's why there's an entry point here. And a stage heart entry point. And then over time, with a certain rate, 0.02 per year. So on average, they'll remain in the state for 1/0.02 or 50 years. They go to a state with heart disease. And we further elaborated this so that their color would change. We had a little variable here. And this oval was set to have a fill color as given by the color of this variable. This is a type color, meaning it can hold values that denote colors, or that it's not denote, they describe colors. And they describe a set of colors. And here, when someone's in this state, their variable is set to green, and that will set this variable, and this oval depends on that variable, and therefore its color depends on this, whatever value is given by this variable. So when it's set to green, it'll turn green. When it's set upon development of heart disease to red, it'll turn red. Here. So here we have a population whose heart disease status varies over time. Over time, a growing number of people develop heart disease. Now, those are good points, but I want to build on them today. And I'd remind everyone that if you need to get this model, it's in that folder. It's in that folder associated with the bootcamp. So in the models built-in class folder in the participant resources shared with all of you. Okay, so we're going to increment this version to version 2 because I'm going to be saving it there periodically. It's going to be version 2. Save it actually auto increments it. If it's a number in the last item here, it'll increment it. So I'm going to make it version 2. So I can always go back to that earlier version. Now, for those, I find that a growing number of people I meet from the health sciences who attend my AI for public health or these boot camps or other factors have actually gotten used to using Git, for example. And Git is an example of source code control systems we've been using in software engineering for, since the 80s, at least I was using them. And I think they go back probably to the early 80s or late 70s. And if you use version control systems, those can be even better solutions for keeping track of versioning, although they have their limitations. I would note that AnyLogic has some basic support both for Git and for SVN, Subversion, which is a previous version control system. TAs, please watch out for people coming in. Thanks. Okay, so when we are we're seeking to extend a model, we often increment it. We often make sure we commit the previous version, and we'll start our work here. So the first thing I'm going to do is I noted that this age is at an individual level because individual people differ in their age. I'm going to show you a parameter that doesn't vary across people. It's shared across the model. And we're going to do this a lot, and I want to emphasize it. Sometimes these parameters will be things used in the global environment. Sometimes they'll be used by individual people, but they won't vary between people. And therefore, the place that they live is a place which is global to the entire environment. It's Maine. It's Maine, folks. So if you go up to Maine, or you go down Maine, here, we're going to go to the palette and we're going to drag a parameter in from this agent area of the palette. So I went to the palette, went down to this agent area, and I'm going to drag a parameter in. Okay. And this parameter is going to denote something that's only one value for it across the whole model. It's going to be population size. Now, you may remember that when we introduced that color variable, we chose it to have a type of color that denotes the possible set of values it could have, set of values associated with colors. Here, population size can take its value from some set, and it's not the set of doubles, which is double precision values. It's not a double precision value. The population size is not a double precision value. It's an integer. So we're going to use this type, and we're going to pull it down, and you actually have to pull down this, pull it up here to the top for these built-in ones. Above double, there's int, and that means an integer, okay? Even better if we could just say a natural number, but such is life. Okay. And we're going to give it a default value. If no one changes it, a scenario in this case, we're going to give it a default value of 1,000. 1,000 people in our population. By default, if a scenario doesn't specify it, doesn't override it, doesn't change it, doesn't alter the assumption, The assumption is that we're going to have 1,000 people. Parameters encode assumptions and communicate them from the point of creation of main, which is a scenario, to where they're used. So this encodes our assumption about population size, and it's communicated from the thing that creates main, which is the scenarios. And baseline, it's going to assume the default value. That's why it's the baseline scenario. We're going to have alternative scenarios coming up, but this is our baseline, and it's going to have 1,000. Okay, so we're going to say a population size of 1,000. But maybe you could tell me, is that enforced right now as the population size? Is that in fact the realized population size, the actuated population size? Anyone remember what the population size was before?
I thought it was 100, but I'm not sure.
It was 100. And where was that? Where was that 100?
I think it was on the person.
It was on person. It was the population. See, it says initial number of agents, 100. Exactly right, sir. Exactly right. The Sarahs are strong in this boot camp. Maybe as always. Okay, so
Thanks.
great. So we have an initial number of agents, and right now it's just a hard-coded value, as we say, baked into it. And we want to change it to depend on this parameter. So we say population size. Okay. Population size. Okay. Give me a second. There's some chat stuff here. Oh, okay. The TAs are hard at work. Thank you, Jeff, for your great illustration. Okay, population size. Now build early, build often. Make sure it builds and that it's a happy camper. Build completed successfully. Okay. Okay. So build, and now let's run it. Run early, run often. It's by running that often you learn too. Running is not something you do just grudgingly to see if it works or see if it, what it does or make sure it runs. No. This is a chance for learning. So there's our population of size 1,000. And why are people turning red over time? Why is the number of red things rising? Because
Become with heart disease.
Yeah, people are developing heart disease. But no, that may sound like a weird question, but I want to come back to this point. Dynamic modeling is about thinking. I'm going to use a term which is sometimes used in a different sense negatively, but it's thinking mechanistically. It's thinking, what are the mechanisms that underlie changes we see? So much of the world, and indeed so many misuses of data, just treat data in its own terms without thinking about the processes that lie behind it. And if we see data over time, we don't think about how it's changing between those time points or what have you. What processes are driving it? Dynamic modeling is about thinking mechanisms, like what are the mechanisms by which one thing leads to another? That's what critical realism is about too. Context, mechanism, and outcome. It's about the different pathways to effect. Some of you, if you have, experience in the more life science, the biological sciences, or with medicine or veterinary medicine, may be familiar with this. If there's a, if you're in large animal clinical sciences and if there's a cow with a calf with a heifer with a cough, you're going to be asking, okay, is this Mannheimia hemolytica? Is this some sort of viral sort of flu type variant? What is the nature of the complaint that gave rise to this? Is it a sign of some sort of chronic, bovine tuberculosis? what's the mechanism by which these things came about? And it's similarly with dynamic models. We ask not just, is the number rising over time? We ask why it's rising. And here it's rising because people are developing heart disease in the model. Because of that mechanism is captured here. We're capturing mechanisms in this model. Okay, so now we have this parameter, and I'm gonna create another one. It's gonna be, another one. I'm gonna create another scenario. Here, we're gonna go up to the model as a whole, and we're going to say create min experiment. How did I do that? I went over here to the projects window, not the palettes, the projects. And I right click on the model as a whole and I say, rustle me up an experiment. Okay. There we go. And the name of this experiment is going to be population. I could call it small population. I'm going to call it population 100. Small is kind of, well, it's small. Okay, so I'm going to say population 100. And I'm going to change it to be 100. And if I run this, what do you think I'll see? If I set the you notice it turned it bold.
Well, they're circles basically.
Yeah. Notice it turned it bold because I altered the parameter value. If you go look at baseline, baseline, that's not bolded because this is the default value. This is actually rather important. But if you look at this alternative scenario, it bolded this because I altered it from the default value. And generally, you want the default value to be what it is in the baseline. And then you have alternative scenarios which let you pose what-if questions with smaller populations in this case. This is very unassuming, but I don't know if you remember that earlier model, but we had like school closures and, people work from home and, people reduced community going and so on. And those were all alternative scenarios. You can stop a model here, and generally it's better to do that than to just close the window. At least I'm more careful about it because I'm always afraid it might keep it running if I don't do that. And not likely, but there's some anecdotal evidence that maybe sometimes it leaves something running mumble that Wade can relate to. Okay. So anyway, so we have now a parameter at the population level that it only has one value for the entire population, so we put it at the main level, the global level. I said population, but it's at the global level. And and then it can be used, in the model, in this case, by the population size. So I'm going to save this model as I want. I doubt anyone has encountered severe difficulties yet, but if you have, I'm gonna put this here model up on the site. Okay, so give me a second. I'm sorry, I'm exhibiting sort of window-based distress. Okay, so come on, let's go put it in the models built in class. Yeah. Okay, we're gonna put that model up, and it's in my models folder. There we go. Okay, so if anyone would like that model, come and get it. Okay. So there we go, and I'm gonna save this model as version 3 for our next stage. So when you see a version of a certain type, oh, it's a well-defined thing. It's not going to just keep on modifying it with the same name. You don't know which one is it. The version is going to clearly delineate what's in that version. I think I'll also stop recording.